Hi everyone, let's start the second part of 6.1 notes now. The essential question is, how do I calculate the missing side lengths and angles of a right triangle? Before starting the lesson, let's have our calculator out. Using our calculator, we can find sine, cosine, and tangent of angles. Using these three, for example, I want to know what is sine of 30 degrees, so I just simply use that and gives me the answer. What is tangent of, let's say, 85? It's this value. So that's how I find sine, cosine, and tangent of angles. Notice that here we are using degrees mode, so these angles are in degrees. Here, if I go to mode, this third line over here can change from radian to degrees or the other way. At this time, we are just using degrees. We will learn about radians later and work with that. But now we're just working in degrees. Okay. So what are the other ones that you see here? Sine -1, cosine -1, and tangent -1. These are the inverse functions of these three. We have learned about inverse functions before. We know that f of x relates x to y. And f -1 of x, which is the inverse function, relates y to x. So sine, cosine, and tangent relate an angle to, for example, sine of that angle. Okay, but if I have sine -1, that one relates sine to the angle. What does that mean? Let me give you an example. For example, I say I have an angle which is 30 degrees. What is sine of that? So you're just going to use sine function and you say sine of 30 is 0.5. That's just a normal function. Now, what if I tell you there is an angle that sine of that angle is equal to, sine of that angle is equal to 0.5. Now I'm asking you, what is that angle? To find that angle, I'm going to use the inverse function. So I'm going to say theta will be equal to sine -1 of 0.5. And that will give me the angle. So notice here, when I'm using sine, the angle is here and the value is outside. But if I'm using sine -1, the value of sine is here and the angle is outside. That's what I'm looking for. So this is basically relating y to x. The other one was x to y. This is y to x. Now let me give you another example. Let's say I tell you I have an angle that tangent of that angle is, let's say, for example, 10.5. Okay, and I ask you, what is that angle? So you're going to use the inverse function. You say theta is equal to tangent -1 of 10.5, and use our calculator. What is tangent -1? I go second tangent. That gives me tangent -1 of 10.5, and it's equal to 84 point something. So 84 theta is 84.55 degrees. That's how I find. Or if I ask you that cosine of an angle is equal to 0.35, for example, what is that angle? So you're going to say theta will be cosine -1 of 0.35, and here second cosine of 0.35 is equal to 69.51. 69.51 degrees. So that's how we use the inverse functions. And notice that inverse functions are totally different from reciprocals. When I'm talking about reciprocals, like sine of theta, for example, is equal to 1/2. Now, cosecant is reciprocal of that, and it's just equal to 2 over 1. It's totally different from inverse function. When I'm using the inverse function, I'm going to say theta will be equal to sine negative 1 of theta, sine negative 1 of 1 over 2. And then I use my calculator. What is sine negative 1? Sine negative 1 of 1 over 2. That is equal to 30. So you see, they are totally different things. This is reciprocal, this one is the inverse. Okay, so having this knowledge, let's start working on this example. This example, we have a triangle, we have two sides, and we are looking for x, the other side, and also theta, this angle. I can easily find the side x here using the Pythagorean theorem, because these are the two legs and this is my hypotenuse. So I say x squared plus 12 squared is equal to 13 squared. Then x squared will be 13 squared minus 12 squared, and it will be, use your calculator, you'll see it's equal to 25, and x will be equal to 5. So we found this using the Pythagorean theorem. Now, how do I use the angle? How do I find the angle? So I'm going to use the given data that I have here. If this is my angle, this one will be the adjacent side. Okay. Now, adjacent and hypotenuse can give me cosine. Cosine of theta, which is adjacent over hypotenuse, is equal to 12 over 13. So there is an angle, that cosine of that angle is equal to 12 over 13. What is that angle? I'm going to use inverse function. Cosine negative 1 of 12 over 13. What is that equal to? Use your calculator. Second cosine of 12 over 13 is equal to 32.2. 32.2 degrees. So that's how I find this angle. Okay, now let's work on this example. In this example, we're looking for this side x and this angle. Once again, finding the side is easy. I'm going to use Pythagorean theorem. X squared plus 4 squared equal to 5 squared. And x squared will be 5 squared minus 4 squared. 25 minus 16, it's 9, and x will be equal to 3. So this is 3. Now, how do I find this angle? Again, I'm going to use the given values. If this is my angle, 4 will be the opposite side, and this one, which is opposite the 90 degrees angle, is the hypotenuse. Using opposite and hypotenuse, I can find sine of an angle. So I'm going to write sine of theta, which is opposite over hypotenuse. It's equal to 4 over 5. Okay, now what is that theta? I'm going to use the inverse function. Theta will be sine negative 1 of 4 over 5. What is that equal to? Second sine over 5. And it's equal to 53.13. So that's the angle. Let's work on next example here. I have one side and this angle, and I'm looking for this one. Okay. Considering this angle, 11 is the adjacent side, and x, which I am looking for, is the hypotenuse. Adjacent and hypotenuse can give me cosine. So I'm going to write cosine of 37 will be. We know that it's equal to cosine is adjacent over hypotenuse. Okay, so adjacent is given, it's 11, and hypotenuse is x, it's what I'm looking for. So using this equation, how can I find x? I'm just going to set the denominator of 1 here and use the cross multiple to solve this. So it will be x times cosine of 37 is equal to 11 times 1. Okay, now how do I find x? I'm going to divide both sides by cosine of 37. I'm dividing by the whole thing, cosine of 37. Because cosine of 37 is going to be a number. If I use my calculator, it's going to be a number. So I cancel these two. Now x will be 11 divided, I'm sorry, let me use a fraction here. 11 divided by cosine of 37, okay, and it's equal to 13.77. So this is how I find x. 13.77, that's this side that we are looking for. Okay, for the next example, again, we are looking for side x first, and also we're looking for angle theta, which is this one. To find side x, again, I have this angle, the hypotenuse is given, and I'm looking for adjacent. Cosine of 60, which is cosine of 60, which is adjacent over hypotenuse, is equal to x over 11, because x is the adjacent that we're looking for and hypotenuse is 11. Now, how do I find x this time? Once again, I'm going to put the denominator of 1 here and do the cross multiple. So if I do the cross multiple, x times 1, which is x, will be equal to 11 times cosine of 60. So let's use our calculator. This time we have 11, oh my god, sorry, 11 times cosine of 60 is equal to 5.5. So now I have the other side, it's 5.5. Now I'm looking for this angle. How do I find this angle? This is also easy to find. I have a triangle and I know that if I add all the angles in a triangle, they will add up to 180. So I know that theta, which is this one, or let's call that, I'm going to just call that A here, A plus C plus B, I know they will all add up to 180. I have the B, which is 60. Also, I have C. This one is 90. And I'm looking for A. So just simply subtract them from 180. So minus, I'm going to write A plus 90 plus 60 is 150 equal to 180. And A will be 180 minus 150, which is 30 degrees. So that's how I can find the other angle. Now let's work on the other example. This time we are looking for this side and this angle. Once again, I can easily find the other side using the Pythagorean theorem. This is my hypotenuse, so I can write x squared is equal to the other two sides to the power of 2. 9 squared plus 12 squared is equal to 225, and x will be square root of 225, which is 15. So I found this side. Now, how do I find this angle? Use the given data, 12 and 19 and 9. This one is the opposite side of theta, and the other one is the adjacent side of theta. Now I can, using opposite and adjacent, I can find tangent. So I'm going to say tangent of theta is equal to I know it's opposite over adjacent, so it's equal to 12 over 9. I have an angle, that tangent of that angle is equal to 12 over 9. Now, what is that angle? Use inverse function, tangent negative 1 of 12 over 9. Okay. Second, tangent of 12. Oh, I'm sorry, it was 12, not 11. 12 over 9. And it's equal to 53.1. 53.1 degrees. So that's how I find the other angle. This was today's lesson, and I hope it was helpful for you. Have a great day.